Okay. So screen is visible.
Yes, sir.
Yes, sir.
Okay. So in previous lecture we started with the Lagrange's mean value theorem. So according to the Lagrange's theorem, if a function f of x is continuous in the closed interval ab, differentiable in the open interval ab, then there exists a point c in the open interval ab such that f dash of c equal to f of b minus f of a divided by b minus a. Alternatively, the Lagrange's mean value theorem may be written in this way also. Instead of writing b, we are considering increment in x as a h. So b is equal to a plus h. So continuity in closed interval a plus h, differentiability in open interval a plus h. Then there exists a theta such that f dash of a plus theta h is equal to f of a plus h minus f of a divided by h, where theta lies between 0 to 1. Remarks. In above statement, in this statement, if we substitute, in this statement, if we substitute f of b equal to f of a, which is condition of the Rolle's theorem, then we'll get f dash of c equal to 0. So Rolle's mean value theorem is special case of Lagrange's mean value theorem when f of a equal to f of b. Now understand what is geometrical interpretation. So according to the Lagrange's mean value theorem, what is required? Continuity in AB is required and differentiability in open interval AB is required. F of A equal to F of B. This is not the condition. So I am taking F of A and F of B over here. They are not equal. Then since function is continuous and differentiable, the curve is smooth. There is no any corner. There is no any gap. Okay. So curve is like this. Now join the point AB, the F of A and F of B. Then we will get a line segment. So there exists at least one point on this curve such that tangent to the curve at that point will be parallel to the line segment AB. This is the statement of Lagrange's mean. Algebraic interpretation. See, f of b minus f of a divided by b minus a. These are the extreme values f of b and f of a. So that is average rate of change of function over the closed interval AB. And that is always equal to actual rate of change of the function f of x at x equal to c. Okay, so the theorem states that the average rate of change of the function over an interval is equal to actual rate of change of the function at some point of the interval. Okay, then we started with different examples. The question is to verify the Lagrange's mean value theorem for different functions. Okay, so first was f of x equal to log x. Logarithmic function is continuous except at x equal to 0, but x equal to 0 is not included. Then f dash of x is 1 upon x, which is again differentiable in the open interval 1e. All the conditions are satisfied, therefore there exists a c in AB such that c belongs to 1e and f dash of c equal to f of b minus f of a divided by b minus a. So b is e here, so f of b minus f of 1 divided by e minus 1. F of x is log x, f dash of x is 1 upon x, a is equal to 1, e is equal to, b is equal to e. Therefore, all the values are substituted in this equation. Right, so 1 upon c equal to log e minus log 1 divided by e minus 1. Log e is 1, log of 1 is 0. Okay, so 1 upon c equal to 1 upon e minus 1. That is c equal to e minus 1. And e is 2.7. So 2.7 minus is 1.7, and no doubt it lies in the interval 1 to e. Next, we started with the next example, f of x equal to x minus 1, x minus 2, x minus 3, which lies in the interval 0 to 4. Then it is simplified to get the polynomial x cube minus 6x square plus 11x minus 6x. F dash of x is obtained, that is also polynomial. Both of them are polynomial, therefore they are continuous as well as differentiable. Then there exists a c such that f dash of c equal to f of b minus f of a divided by b minus. Considering this as f of x, f of b, that is f of 4 is obtained 6. F of a, that is f of 0 is obtained minus 6. Then f dash of c is 3c square minus 12c plus 11. All these values are substituted over here. So we have 3c square minus 12c plus 11 equal to 3. Then we get the quadratic equation 3c square minus 12c plus 8 equal to 0. Then it is solved to get the value of c. Then in the same way, the next example is also solved. Again, in this case, c is equal to plus minus 1. Okay. Then we solve examples on the inequality. Okay. So suppose A, B, C are positive numbers and say A is less than B is less than C. Then A square will be less than B square will be less than C square. If you take reciprocal 1 upon A, 1 upon B, 1 upon C, the inequality sign will change. If we add minus sign to every number, minus A square, minus B square, minus C square, for example, then the less than sign will be converted into greater than. Okay. So next question was to prove that B minus A divided by 1 plus B square is less than tan inverse B minus tan inverse A is less than B minus A divided by 1 plus A square, provided A and B are positive and B is greater than A. Okay. And then we have to deduce these two results. So we considered f of x equal to tan inverse x, right? We constructed this function. Function is not given in example, that we decided from tan inverse b minus tan inverse. Yeah. So tan inverse x was taken. Then f dash of x is obtained 1 upon 1 plus x square. Tan inverse x is continuous in AB. It is not continuous at x equal to 0, but 0 is not included since A and B both are greater than 0. Therefore, okay. Then f of x is differentiable in open interval AB. So all the conditions of Lagrange's mean value theorem are satisfied. Therefore, there exists C such that f dash of C equal to f of B minus f of B divided by B minus A. That is tan inverse B minus tan inverse A divided by B minus A equal to 1 upon 1 plus C square. Okay. Now, see the question is to prove b minus a divided by 1 plus b square, b minus a divided by 1 plus a square. So question contains 1 upon b square, 1 upon a square. So these two terms are required, and fortunately we have 1 upon 1 plus c square in the equation number 1. Therefore, the relation between a, b, c is obtained in this way. A is less than c is less than b. C lies between a, b. Therefore, c will be between a and b in inequality. Okay. Squared, no change. 1 is added, no change. Reciprocal is taken. Change is there, inequality will change. And then using equation 1, the value of 1 upon 1 plus c square is obtained, and then it is multiplied by b minus a to get the required solution. Next, to deduce this result, we considered a equal to 1 and b equal to 4 by 3, and it is simplified to get the next result. Okay. I think in one of the division I solved this example. I think B division I solved example. In A division it is remaining. If I get time, I will solve the example. Else I'll provide you the notes. Example is simple. See, to prove that B minus A divided by root of 1 minus A square is less than sin inverse B minus sin inverse A is less than B minus A divided by root of 1 minus B square. Provided A is less than 1, B is less than 1, and B is greater than A. And hence, we have to deduce this result. So, as in previous case, we consider f of x equal to tan inverse x. Here, we have to consider f of x equal to sin inverse x. Okay. And it is in the interval AB. F dash of x is obtained 1 upon root of 1 minus x square. F of x sin inverse x is a continuous function. Okay. Then 1 upon 1 minus x square become infinite at x equal to 1. But already we consider a and b less than 1. Therefore, f of x is differentiable also. So the continuity and differentiability condition of Lagrange's theorem are satisfied. Therefore, there exists a C such that f dash of C equal to f of b minus f of a divided by b minus a. F of x is sin inverse x. F dash of x is root of 1 minus x square. So f dash of C is obtained 1 upon root of 1 minus c square. And f of b minus f of a divided by b minus a is written. Sin inverse b minus sin inverse a divided by b minus a. Then, as usual, since C lies between A and B, we will start with this relation. A is less than C is less than B squared. Negative sign is added. Negative sign will change the inequality sign. Then 1 is added, no change. Root is taken, no change. Reciprocal is taken. Again, there is change in the inequality sign. And 1 upon the root of 1 minus c square is sin inverse b minus sin inverse a divided by b minus a. That we have already written here. Sin inverse b minus sin inverse a divided by b minus a equal to 1 upon root of 1 minus c square. That is used here. Okay. And then the whole equation is multiplied by b minus a to get the required result. To prove this, you have to choose the correct value of a and b. That's it. This is what we have studied till. Okay. Next few examples. Straight up. Now write on the notebook.
So
Any doubt?
students are waiting outside. Please
Acha,
let
acha,
them in.
okay, okay, okay. Okay, so let me start. Right on next part, sign of the derivative. Right, sign of the derivative. Okay, so right on. Increasing function. So say I have a function y equal to f of x, and the graph of the function is like this: x-axis, y-axis, origin, and I have a graph like this. Graph of the function y equal to f of x. So say I take one value of x here, a, and another value of x, b. What is the relation between a and b? B is greater. Okay, and I'll take the corresponding values of the function. Say f of a here. Let me extend the graph and say f of b here. So, what is the relation between f of a and f of b? Who is greater? F of b is
For
greater.
B.
So, f of a is smaller and f of b is greater. And therefore, function is increasing. See, value of function may be here, say, 1, for example, y equal to 1. Here, y equal to 2, say. Here, y equal to 3. Say here, y equal to 4. Y equal to, say, 5 here. Y equal to, say, 6 here. So, values are increasing everywhere. Okay, so function is known as increasing function. Okay, draw the graph and below that right now. Draw the graph. Then write. A function y equal to f of x is said to be increasing. A function y equal to f of x is said to be increasing if f of a is less than f of b. Okay, for all. For all, I don't have space here. B greater than a or a less than b. So whenever a is less than b, f of a should be smaller. Then the function is said to be increasing. Okay, then decreasing function. Again, let me draw the graph. Say I have a function x over here, x-axis, y-axis, and I have a function y equal to f of x like this. Okay. Now suppose I have x equal to a here and x equal to b here. Again, what is the relation between a and b? A is smaller only, right? Let me find the functional value, that is value of y. Okay, so f of a here. But where is the f of b? F of b is here. Okay, so who is greater out of f of a and f of b?
F of A.
F of a is greater. Right now? And see the functional values are decreasing. Say y equal to 10 here. Y equal to say 8 here. y equal to say 6 here, okay, y equal to 5 here, and so on, right? Now values are decreasing. Okay, draw the graph. Draw the graph. Then, right, a function y equal to f of x is said to be decreasing if f of a is greater than f of b for all a less than b. Okay, then right, remark. Right, consider a function y equal to f of x. Right, 1. Just 1 minute. हाँ बोले सर. लेक्चर में चलता है. Right, a function y equal to f of x. Okay, right. If f dash of x is greater than 0 in an interval AB, then function is increasing in that interval. Important, remember. Right. If f dash of x is less than 0 in an interval CD, then the function is decreasing in that interval. Function is decreasing in that interval. Okay, examples. Hello.
F dash is equal to 1.
You are not audible.
Sir, if x is equal to 0, then
that I am asking just 1 minute. Tell me what will happen if f of x equal, sorry, f dash of x equal to 0?
Increasing or decreasing? You are increasing or decreasing?
Neither increasing nor decreasing.
So what type of function it will be? Which function is neither increasing nor decreasing? Any example of the function which is neither increasing nor decreasing?
X is equal to 1.
X equal to
1.
So constant function, na?
हाँ.
Right. So every constant function you write this inside. This is for your information. Write down. When I'll also write. When f dash of x equal to 0, it implies f of x equal to what? Constant. Constant function, or do you write constant only sufficient? Okay. So for example, for understanding, write example so that there will be no any confusion afterwards. Right. For example, we used to write y equal to f of x, na? So equal to some constant. Say y equal to 10. So y equal to 10 graph will be like this. Na? This is line y equal to 10. So if we try to draw tangent to this curve at any point, that will be parallel to x-axis, and therefore what will be the slope? 0. Okay. Slope 0 means derivative 0. So if we take derivative, what is derivative of 10? 0. Understood? So in simple words, if derivative is 0 for a function, then the function is constant. Lecture नंतर थोड़ा चल examples write examples. Show that f of x equal to x cube minus 3x square plus 3x plus 2 is increasing in every interval. So it is increasing function, that's it. Everywhere it is increasing. Okay, so solution. Right, here f of x equal to x cube minus 3x square plus 3x plus 2. Find f dash of x. 3x square minus 6x plus 3. Achha. So now we want to show that f dash of x is greater than 0. So how to show this? Very simple. Take 3 common. What will happen? X square minus 2x plus 1. And what is this? X minus 1 square, na? Right, now you take any value of x. Okay, this is for example. You don't have to write this in exam. Okay, so I'll write for example x equal to 5. See what is f dash of 5. X equal to 5. 5 minus 1 is 4. 4 square 16. 48. Is it positive? Yes. Okay. Take x equal to minus 3. See what happens. F dash of minus 3. So minus 3 minus, acha, again we are getting same 48 only. That is also greater than 0. Take x equal to 0. See, f dash of 0 equal to 3, greater than 0 only. Okay. So for all values of x, it is greater than 0 except at x equal to 1. What happens at x equal to 1? F dash of 1 equal to 0.
0.
Right? Na? F dash of 1 equal to 0. Everywhere else it is na positive. So at one point only it becomes 0. Again 0 we can consider as positive number only. Okay. So that up. F dash of x greater than 0. Therefore function is increasing in every interval. Understood or not? Example is clear?
Yes, sir. Yes.
Okay. This is not to be written in exam. This is only for your understanding. And those who want to prepare for the higher studies, maybe GATE exam, maybe civil services, engineering civil services exam, this type of examples are very important. Let me continue. Right. Next example. Separate the interval just a minute. Separate the interval in which following function is increasing or decreasing. 2x cube minus 15x square to x cube minus 15x square plus 36x plus 1. So done. Solution. Right. Given f of x equal to 2x cube minus 15x square plus 36x plus 1. Okay. Done. F dash of x equal to take 6 common. Find roots of this equation.
2 and 3.
Absolutely. See, these values of x equal to 2 and x equal to 3. That will divide the whole real line. This is the real line. Okay, which starts from minus infinity up to plus infinity. That will divide the real line in 3 parts. Okay, so 3 intervals. So one is minus infinity to 2. Okay, that is x between minus infinity to x equal to 2. This is the first interval. Okay, now see what happens to the f dash of x in this interval. So take any value of x between minus infinity to 2. Okay, so let x equal to 1 and see what is f dash of 1. F dash of 1 equal to 6. 1 minus 5 plus 6. Positive?
Yes, sir.
Greater than 0. So what is conclusion? Function is increasing. And you can check it for any value of x which is less than 2. You will get that the value is positive only. Okay, value will be different but will be positive. So function is increasing in minus infinity to 2. Okay, now take say next interval x between 2 to 3. Okay, so let x equal to 5 by 2, 2.5. Okay, so f dash of x equal to 6 x square. F dash of x, let me write it here. X square, so 25 by 4 minus 5 into x 5 by 2 plus 6. You can use calci for this. Can anyone tell me what the answer is? Use calci and tell me the answer. I think it is minus 6 by 4. Check this. Is it minus 6 by 4?
Yes, sir.
So Rana, function is increasing or decreasing?
Decreasing.
Decreasing. You have to mention the interval in. Don't write only decreasing. You have to mention the intervals, right? 3 to infinity. Let x equal to 4. F dash of 4. 6. 16 minus 20 plus 6. 12. The function is increasing.
सर
हाँ हाँ
ये एमसीक्यू में आएगा इतना तो
ये एक आएगा ना
तो सर ये मतलब इतना x की वैल्यू करके सब्स्टिट्यूट करके ही सॉल्व करना पड़ेगा क्या सब?
Absolutely. What the question will be, function will be given and it will be asked, what is the behavior of function in the interval 3 to infinity.
ओके सर, ओके, थैंक
है
यू।
ना? Okay. Next. चलो नेक्स्ट सॉल्व करते हैं। Let me change the page. Right, next part. Cauchy's mean value theorem. Last part. Cauchy's mean value theorem. Cauchy's mean value theorem. Done. Statement: if f of x and g of x are any two functions of x such that both functions are continuous in closed interval AB. Second, both are differentiable in open interval AB. Third, g dash of x not equal to 0 for any value of x in AB, then there exists at least one point x equal to c in AB such that f of b minus f of a divided by g of b minus g of a equal to f dash of c divided by g dash of c. See, it is same as Lagrange's mean value theorem, right? Na?
यस सर।
What should be the condition so that it will be same as Lagrange's mean value theorem? What should happen so that it will be same as Lagrange's mean value theorem? Lagrange's, what is statement of Lagrange's mean value theorem? F dash of c equal to f of b minus f of a divided by
b minus a.
b minus a. So what should happen so that we'll get this statement from above statement. Acha, you might have understood. Suppose this is the statement of Lagrange's mean value theorem for the function f of x. Tell me what will be the statement for the function g of x. It will be like this: g dash of x equal to g of b minus g of a divided by b minus a. And if we divide both of them, f dash of c divided by g dash of c, what will happen? B minus a will cancel and we will get f of b minus f of a divided by g of b minus g of n. That is what we have written in the statement of the Cauchy's mean value theorem. Getting that?
Yes sir, getting.
Right. And then the third statement, see, g dash of x not equal to 0 is written. or any value. If g dash of x equal to 0 means g dash of c equal to 0 and 1 upon 0 will be infinity. Okay. Therefore, the third condition is added. Now, suppose I have g of x equal to c. Sorry, x. Tell me what will be g dash of x. What will be the
1.
derivative of x? 1. Right now? Now, substitute g of x equal to x in this statement. Okay. So, what will get? F dash of c as it is. What is g dash of c? G dash of x equal to 1. So, what is g dash of c? 1 only. Na? So, divided by 1. Equal to f of b minus f of a. Right. Divided by g of b. G of x is x. So, what will be g of b? B. Na? What will
B.
be g of a? A. Okay. So, we'll get b minus a. And this is the statement of the LMVT, Lagrange's mean value theorem. Okay. So, Lagrange's mean value theorem is special case of Cauchy's mean value theorem. When g of x equal to x. Remark. Hope this is clear. LMVT, Lagrange's mean value theorem, is special case of CMVT, Cauchy's mean value theorem. Right. When g of x equal to x second. That is sufficient. Okay. Examples. Let me change the page.
One minute, sir.
Yes. Acha, you want to write it? Okay. Acha, next, done. Let me change the page. Right. Verify. Examples. Verify CMVT, Cauchy's mean value theorem, for following functions. One, sin x and cos x in the interval 0 to pi by 2. Sin x and cos x in the interval 0 to pi by 2. Solution. Let f of x equal to sin x, g of x equal to cos x. Okay, and the interval is AB interval is there, na? That is 0 to pi by 2. Then that one, f dash of x equal to cos x, g dash of x equal to minus of sin x. Then that one, both f of x and g of x are continuous in 0 to pi by 2. Right? Both of them are continuous in the closed interval 0 to pi by 2. Okay. Then now see, f dash is cos x and g dash is minus sin x. So both f of x and g of x are differentiable in 0 to pi by 2. What is known of g dash of x sin x? When it becomes 0, G dash of x not equal to 0 for any value of x in open interval AB that we have written. When sin x becomes 0 for x equal to 0. But x equal to 0 is not included in the open interval. It is included in closed interval, but not in the open interval. So G dash of x is not equal to 0 for any x in the open interval 0 to pi by 2. Open interval means 0 is not included. Okay, so don't get confused. Don't say that sin x becomes 0 at x equal to 0. No doubt it become, but 0 is not included in the open interval 0 pi by 2. Okay, now written all conditions of CMVT are satisfied, therefore there exists a C belongs to 0 to pi by 2 such that right f of b so g of a f dash of x is cos x substitute all these values in the statement of the CMVT and you will get the required answer. Please do that yourself. Let me change the page.
1 मिनिट सर.
Oh, okay, no problem. Right.
सर वो साइन अपॉन कॉस जो इसको कन्वर्ट करना है या वैसे रहने देना है?
Somehow we want to find C, so we have to convert it.
ओके सर.
Okay, so let me change it. We have all the values now. Let me change it.
cot inverse -1 है.
So what is cot inverse of -1? F of b minus f of a divided by so -1 minus 10 cancel. This is okay. C is equal to pi by 4. Next. Hope you might have understood it. Start on next example. Can we go through the next example?
Yes, sir.
Yes, sir.
Okay, start. In CMVT, f of x equal to x square, g of x equal to x belongs to closed interval AB, then show that C is arithmetic mean of A and B. Arithmetic mean, harmonic mean, geometric mean, you understand? No?
Yes, sir.
Okay. So, right here, f of x equal to x square, g of x equal to x, f dash of x is 2x, g dash of x is 1. Both f of x and g of x are polynomial. So, they are continuous in AB. Next, both f dash of x and g dash of x are polynomial again. So, they are differentiable in AB. Next, f dash of x, sorry, g dash of x equal to 1 is not equal to 0. G dash of x is 1, which is not equal to 0. Okay, brother. All conditions of CMVT, all conditions of CMVT are satisfied. Therefore, there exists a C such that you can skip this part. A is A only, B is B only. So f dash of C 1, G dash, f dash of C is 2C, f of B, f of x is x square. Next, first, huh? Have to take attendance also. Understood, na?
Yes, sir.
Right. Considering f of x equal to 1 upon x square, f of x equal to 1 upon x square, g of x equal to 1 upon x, prove that c of CMVT is harmonic mean of A and B. Okay, so here
सर हार्मोनिक में मतलब 2 upon a plus b का
कोई बता सकता है हार्मोनिक मीन क्या होता है?
2ab by a plus b.
हाँ, करेक्ट. 1 upon a plus 1 upon b. 2ab divided by a plus b. Right inside, harmonic mean of ab is 2ab divided by a plus b. चलो सॉल्व करते हैं. Right here, f of x equal to, और ज्योमेट्रिक मीन क्या होता है ab का? रूट ऑफ ab. राइट इनसाइड. मैं लिखता हूं. और कोई मीन रहता है क्या? Is any other mean is there? अच्छा चलो सॉल्व करते हैं. राइट. Right, both are continuous in AB. Something arithmetic को geometric mean. Google it. Arithmetic को geometric mean. Both of them are continuous in AB. Both of them are differentiable in AB. G dash of x is 0, but for x equal to 0. Acha, for infinity.
So it is the multiplication of AB, AP and GP.
हाँ, correct. What do you want to say? Multiplication of AP and GP? No, na. Harmonic mean. No, concept is different, no. Here we have written it for A and B only. If you write A, B, for A, B, C, it will be different. So just don't find conclusion from A and B only. Harmonic mean is 1 upon A plus 1 upon B. Okay.
He was talking about that other mean you told. Google it.
Achha. Okay. Can I change the page?
Yes, sir.
Okay. Right now, next. Let me complete the example. First, I have to take attendance also. So, where we are? Right. According to
सर पेज नहीं चेंज किया.
अच्छा अच्छा, सॉरी, जस्ट आई एम राइटिंग इट हियर ओनली. ओके 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 ओके. Alright. According to CMFT, f dash of C divided by g dash of C equal to f of B minus f of A divided by g of B minus g of A. So f dash was minus 2 divided by x square cube, sorry. Right, minus 1 upon x square. F of B 1 upon B square minus 1 upon A square 1 upon B minus 1 upon A, simplified. Minus minus sign will cancel. 2 by C cube C square by 1. This will be A square minus B square divided by A square into B square into A minus B AB. Okay. C square will cancel. 2 divided by C equal to AB will cancel. AB will remain. This will cancel. A plus B will remain. AB. Okay, this is all about this unit. Solve the MCQs. I'll provide you MCQs today. Hope you might have gone through the NPTEL lectures of the unit number 1. NPTEL lecture देखे किसी ने? Have you seen the NPTEL?
नो सर अभी तक.
देखो ना क्या प्रॉब्लम क्या है. Go through them. Understand them. Attendance of
Yes, sir.
A division. Huh? Once you give the attendance, you have to leave from the classroom.
Sir, that expansion of indeterminate form you told about the date, sir. डेट के बारे में सर, वो आपने 27 बोला था सर, लेकिन बाद में मैंने किया तो सर वो डन लेट बता रहा है वहाँ.
ठीक है, मैं उसको देखता हूँ. पहले आप अटेंडेंस दे दो, पहले उसको अपलोड करो. ठीक है, चलो.
अपलोड
ए
कर दिया
डिवीजन.
सर.
हाँ, नो प्रॉब्लम. रोल नंबर 1.
Present, sir.
2 fast.
Present sir.
3
Present, sir.
4
Present, sir.
5
Present, sir.
6 6